Hello and welcome to Module 2 in Networking Essentials. This is the first, I think I've talked about this before, but this is the first kind of step that you're going to take on your journey to your CCNA. Also, if you just want to get your Net Plus or any other certifications, any cybersecurity certifications, then this is a great course for you to take as well, because it's going to give you the solid baseline that you need to be successful in a job in IT or cybersecurity. So today we're going to talk about online connections, okay? We're going to talk about three main ones. Number one is wireless networks. Number two is local network connections, kind of talk about what's required for devices to communicate on the network. And then finally, we're going to talk about network documentation, okay? So like why is it important? I talked a little bit about this before. What are the different types of topologies? And if that's a new word, think of topology like the layout, if you will, the lay of the land. So those are the three main things that we are going to talk about. When it comes to everything in this lecture, I also went out and found some supporting videos, and you can find those in Google Classroom if you are in person. If you are online, I will post links in the description to those videos as well. So let's go ahead and get started. First and foremost, wireless networks. And when people think about wireless networks, they tend to think about Wi-Fi, if you will. But in this chapter, I want to dig into a few other wireless networks that we kind of communicate with or interact with. So what a lot of people also don't realize is just how many wireless networks, different wireless networks, are devices that we carry every day in our pocket, what they connect to or what they utilize on a daily basis. So when it comes to our phones, first and foremost, they have a cellular reception. Okay, so that's why they're called cell phones. Okay, and with that, we send the message out to a tower, and then that tower then relays that message. It eventually will get onto the rest of the interconnectedness of the internet, which is what we talked about in the last chapter, and that message will find its way. Okay, and then within milliseconds, that device that you're communicating, let's say we are sending a message, we're sending a text message. It's going to go across that network, and then within minutes, sometimes even seconds, the person on the other side will get that reply. And I strongly urge you to watch the supporting videos that are in this module, because it's super interesting just how good cell reception has become and how fast it can go from point A to point B. That is what I love about technology is I've been able to watch the growth of all these different technologies over the years, and what a lot of students take for granted today of that kind of instantaneous, when you go to a website, boom, it's there. Have that thirst for knowledge to find out how that actually works. And I promise you, going down that rabbit hole, you will find success because you're learning what the underpinnings of these networks are. And that's also a way, kind of a litmus test. One of my students is like, I don't know if I want to go into networking or cybersecurity, and he's gone back and forth all year. And what it comes down to is, what could you spend hours just watching videos or learning more about? Okay, so I'll get off my soapbox. For a moment, I just love that deep research, that lifelong learning aspect that I get to partake in every single day. So first and foremost, mobile phones will use radio waves. They'll transmit those signals to antennas that are mounted on towers in certain areas, and then they will make that hop. That voice call will then make those hops to another cell phone tower until, like I said, it hits the rest of the network, the wired network. Also, text messages kind of work that same way in that relay fashion. So when we think of cell phone, it comes in a few generations. Okay, so that's what the G is in 3G, 4G, 4G LTE, and now what we're seeing more and more is 5G. This is the generations of wireless, and most of the time, we're on 4G or fourth generation, or even, as you can see here, a lot of the traffic is, especially between, 2017 and then this year, 2022, is that most of the traffic is 4G, but we're starting to see 5G kind of get more of a hold. I would say if we looked at this graph again in a year, a lot more traffic or a lot more of the data that goes through the cellular networks are going to be 5th generation. It's just because it takes a minute for cell phone manufacturers to adopt this new technology, and also it takes time for the cell providers like Verizon, Sprint, T-Mobile, AT&T. It takes a while for them to build out their network, and they all use different technologies as well. So like I live in very rural Ohio, and 5G is gotten more and more prevalent. I got the Pixel 6 about 3 or 4 months ago, and I get amazing data speeds from my home, and I live in a town that doesn't even have a stoplight. So again, we're seeing more and more of that 5G be more ubiquitous or more spread out or more available to others. So it's important for this slide just to know that we are now on 5G. 4G LTE is still good, and the G stands for generation. So what are some of the other networks that our cell phones interact with on the daily basis? Well, GPS is something that has been around for a really long time, and in the supporting videos, I shared a video not only of how it works, but why it's free or free use. I remember back in the day when Garmin and TomTom put out these devices, and they use GPS signals in order for you to find your way. Well, now that's just kind of built into, and it's just like you just expect your phone to be able to do that, okay? Have that GPS turn-by-turn directions, and you don't even pay anything for that phone or for that app. So again, our devices that we carry on a daily basis are constantly evolving to and kind of taking on this other technology that you used to have to purchase separately. So what's nice about the GPS that we have today, you can actually get an accurate signal within feet sometimes. I mean, you have to use some other technologies, but you can get within just regular GPS location accuracy up to 10 meters. And like I said, there's other technology that's at play, and you can actually get like wireless networks, Bluetooth beacons. They can actually get you even closer, even more accurate. And from the programming side, like I've developed iOS apps, and in the actual API, you can choose like how accurate you need the GPS to be based on your application. Now, obviously, the more accurate it is, the more battery is going to be needed. So you will see a little bit of a sacrifice when it comes to using those apps and being more specific to the actual accuracy of that device. Next is Wi-Fi. This is something that, again, is super ubiquitous these days. You have hotspots, which is basically where, Wi-Fi is available, but everything from Target to Walmart to, McDonald's, all these places have Wi-Fi available. So what's nice about that is if you don't want to, waste your cell phone data, if you don't have that unlimited plan, you can have it so whenever you walk right into Target, Walmart, wherever, it automatically connects to the wireless signal there. So another one is Bluetooth. Bluetooth allows us to connect our smart devices such as our smartwatches, headphones, speakers. This is a low energy connection that is really meant to replace, I look at it as short cords. Okay, so if I could plug a phone into a watch, that's replaced with Bluetooth. If I would normally plug my phone into a pair of headphones, that's been replaced with Bluetooth. If I would plug my phone into my car for audio, that's short enough that I would plug a cable in, that's Bluetooth. Okay. The reason that I make that correlation or explain it that way is because Bluetooth has a limited distance in which it can connect, about 30 feet, and even that is pushing it. It's meant to be in very close proximity to your devices. NFC, which is even closer, that stands for near field communication. This almost has to be touching the device in order to communicate, and this tends to be more for like at first it was used for contact sharing. So if you met somebody like at a conference, you could like tap your phones together, and all of a sudden like you can share information. I didn't see that widely used. I've used it for like checking into buildings. So I would put an NFC tag on the front of the building, and I would tap my phone against it just for me to keep kind of notes on where I was at different times, and also kind of help me manage my time a little bit better. But mostly you're going to see this used for payment processing systems. So the next is local network connections. So there's a couple different components that you need to be aware of. And I talked a little bit about this in the first chapter, but let's take a little bit deeper dive in this module, okay? First and foremost is hosts. So hosts can be a lot of different things. You know, it's not just the desktop computer that is in a user's office, okay? It could be a printer, it could be a, it could be a laptop, it could be a tablet, it could be anything that an end user would interact with is what I would consider a host, okay? Copy machine would be a host. Telepresence or like a conference room technology, those would all be hosts. From there, we have peripherals. So peripherals don't necessarily talk on the network, but they require another device in order to have access to the network. Okay, so that sounds kind of confusing, but if it is a standalone printer that you plug a network cable into, it's a host. If it's a printer that is plugged in via, say, USB to a machine like a laptop or a desktop in a room, and then it is shared on the network, that becomes a peripheral. Okay, peripherals can also come in the form of webcams, any devices that you physically plug into a computer would be a peripheral. Next, we have network devices. Network devices are things like switches, routers. I hope there's no hubs out there, but this is networking hardware that is designed to route and relay traffic on the actual network itself. Access points would also fall under this category. And then finally is network media, and that is the physical connections or wireless. I mean, you can have wireless point-to-point. I talked about that in a previous lecture. But with this is like fiber optics, the actual twisted pair cable, wireless, the actual media that connects all of your network devices, or technically hosts too. Those hosts will connect to network devices, which then connect to each other. Okay, so what is the most important thing that you are going to learn in this module? This slide right here. Okay, without a doubt, this is the most important slide in this entire module, and arguably, maybe even this entire course itself, and that is what is required to connect a device on a network in order for those hosts to be able to communicate, okay? First and foremost is the IP address, okay? The IP address is going to identify the host on the network, and a couple, like we're going to do a whole section on IP addresses, but what's important is two hosts can't have the same thing. Think of it like your address at home, okay? If you and your neighbor had the same IP address or the same address, the same mailing address, would the mail person know where to put the mail? They wouldn't, right? And there would be a lot of confusion. So same thing when sending email. If I was sending out a message to somebody and it had two addresses, I wouldn't know if it got to the right person, okay? Next is Subnet Mask. So Subnet Mask is going to identify which network the host is connected to. And again, we're going to break this down even more. Just as of right now, I just need you to be aware of the idea of a Subnet Mask. So if you look on the right-hand side here, you'll see that the let me pull up my little I was going to pull up my little pen. But where it says Subnet Mask, it's the second box over here on the right. It has 255, 255, 255.0. Wherever there are 255s in that case, that tells us what the network is. So in this case, our network is 192.168.1. Okay, and where that 0 is, so coinciding with the number 1, that is going to be the actual IP address or identifying the host on the network. Okay, and again, we're going to break this down in much further detail in another lecture. And then finally, default gateway. This identifies the network device. This identifies basically how you get out of the network. So let's say a request comes in and you need to go to the 10 10.10 network, then you're going to have to know how to get out of your own network, because again, we want to segregate or separate all of our network traffic, and then that helps with things like broadcast and broadcast storms and just overall traffic on the network. Like if everything was just on one big network, it would be super, super slow because, again, we talked about bandwidth in a previous module, but basically it would get very, very congested. So that's why we separate these networks and give everybody their own identifiable or their own IP address to identify who they are on this network. So now let's talk about how you actually get those different settings. So again, just remember IP address, subnet mask, default gateway. Okay, so those are three of the four pieces that you need to connect to. Those three for the network, but then there's a fourth that we're going to talk about in DNS that you need for being able to type in like google.com, and then how do you actually get there, okay? So there's two different ways to get an IP address. Okay, first and foremost, you can go in there to this dialog box that you see here, and you can check that little box that says use the following IP address and type it in, and you're good to go. Okay, so you can manually put in all that information. The other option would be to use what's called a DHCP, or Dynamic Host Configuration Protocol server, DHCP server. And with that, what we would do is we would actually leave that little bubble where it says obtain an IP address automatically. And again, I'm looking on the right-hand photo. And if you check that box, what's going to happen is the host is going to make a call when it connects to the network and says, hey, where can I get an IP address? Okay, and then the DHCP server is going to say, hey, here's an IP address. Let me look. Okay, well, here's my MAC address. So a MAC address is the kind of serial number that's burned into the network interface card. So the server will then look and say, hey, have you been here before? Okay, have you requested an IP address before? If yes, then I'll see if there's a reservation. And if there is a reservation, I'll give you that IP address. Otherwise, it'll just give it its next available IP address, okay? So I want you to take a couple seconds, pause the video, and I want you to think about what are the advantages and disadvantages of a manual IP address, you going in there and typing it in, or using DHCP, because both of them have pros and cons. So pause the video here, and then we will talk about that here in a second. Okay, so let's look at the pros and cons of DHCP or typing in an IP address. So why would you want to manually type in an IP address? Well, with things like printers or things that kind of are always going to be on the network, you might want to go and enter that IP address information in, and then you can set up like a bunch of devices. Let's use a copy machine, for example. With a copy machine, I am going to set the IP address manually, and then I am going to go to the machines and I am going to type in the IP address because I always know what it's going to be, and boom, printing is going to happen. That you don't want things to change when it comes to peripherals or devices that people depend on. Okay, so if the printer changed its IP address every once in a while, then anytime someone would go to print, they're not going to be able to see that, right? So one of the disadvantages of manually entering it is configuration issues. Again, a human issue where you might mistype something. Also, if you manually set an IP address, a couple things happen. And these are all from experience. Number one is you forget that you set an IP address, and then you're working on another machine and you set it statically as well, or you give it a manual configuration, and you accidentally set it as the same IP address. There's not really something, unless you look at like the network traffic, to see that two devices have the same IP address. So I've actually had this happen before where I set up a printer and then I went and set up something else, maybe a camera or something. I don't remember. It was like 10 years ago. But I used the same IP address because I didn't take good notes and I didn't have great network documentation of what I had set that printer IP address to. And basically, people were sending print jobs to my cameras. Okay, so they were sending this traffic, and obviously they were sending tickets to say, hey, I can't print. and that's because I had, used that IP address. So I would have two addresses. So back to my analogy with sending letters, basically someone else's mailbox was filling up with letters in that case because I had set the IP address to the same thing. So that's definitely a con. With those pros and cons, you can actually achieve a similar thing for DHCP, okay? Because if you have manual IP address and then you also have DHCP running on the same network, you could potentially have that DHCP server pass out that same address, okay? Because the DHCP server has a list of IP addresses it could pull from, and it doesn't know about the static IPs that are out there, okay? So if I set up a DHCP pool that is between 100 and 200, and then I manually set a printer to 105, that DHCP server is going to still hand out 105. It has no way of knowing that you set that. So what I recommend, and it's been my best practice over the years, is to set up what's called a reservation in DHCP. So with that, we get all the benefits of a manual IP address, except we actually go into our DHCP server. We can go and create a new reservation. With that, you just type in the MAC address of the computer that's going to be making the request, and then the IP address that you want it to have. So then, let's say we have a new copier coming in. I'm going to reach out to the company that's installing the copier and say, hey, what is the MAC address? I'm then going to go into the DHCP server before they even get here, and I'm going to set up that IP address assignment. And then when they get here, it's all configured. And I've had them come to me and be like, okay, what do you want this IP address to say? Just plug it in. That's all I need you to do is plug it in. It'll get its IP address. I now have documentation. It's in the scope that it needs to be in, and it's all set, ready to roll. So you can still do static addresses, but you do that through the form of reservations. So if you want to play around with this, I would say, install a virtual machine and install, Microsoft Server. You can get it for free, like a free trial of Windows Server, and, play around with DHCP a little bit. You could also do it with your home wireless router, okay? And we have some labs in the future that will go into, playing with that, but you can do DHCP and reservations in most home wireless routers. So hopefully that makes sense on manual versus automatic or DHCP address assignment. If you do have questions, please leave it in the comments or shoot me a message. So now it is lab time. So if you are in my in-person class, there is a lab in Classroom or the LMS that we're using. Go ahead and you can either work on that now, pause the video here and work on that now, or you can keep going with the lecture and then come back to that lab. Network documentation. Okay, so I talked a little bit about this in the previous module, but also, just with my example of having bad documentation or not having updated documentation and it causing me issues. Okay, so device names and address planning. So this is something that in the different jobs that I've worked, I've really tried to put a lot of thought into a naming scheme. Okay, so with that, you want to be able to look on the network and be like, I know exactly where that device is. The name should say that. So it shouldn't be like teacher's last name dash laptop, because that teacher could get a new job next year, or they could become an administrator, or they could win the lottery. You know what I mean? So that is not a concrete thing. But what could be concrete is, the room that they're in. Obviously that changes too. But you have to come up with whatever you think is good for your environment. Okay, so one of the ones that I've used in the past is like device type, actually building dash device type dash location. So HHS dash PC dash 203. Okay, so I knew that, and then it would be like dash 1, dash 2, dash 3, whatever it was. So I knew that that device was at the high school. It was a PC. I know the room that it was assigned to, and then it has its own number. Okay, so in the case here, if we look, and it's the computer here in room 209 in the orange little bubble, my name is C209-1, and I'm in building C, room 209. My IP address is 192.168.3.1. So the only problem that I see with this is, what are you? So I might add to this like dash printer, or I would always use dash LP to signify printer, dash MD for mobile device. Like you can come up with whatever your scheme is, but it's important that you take time and think about it. Don't just like when you're setting up the PC for the first time, you give it a random host name. Okay, you want to have it fall within whatever your standard is. You want standards and no compromise. Network topologies. This is something that can be a little bit confusing, but there are two different types of topologies. There is a logical topology and a physical topology. So a physical topology is going to show where wiring is installed and the locations of networking devices that connect the host. These diagrams use symbols or icons to represent the different devices and connections that make up a network, okay? So here on the right, we're going to see different end devices. We're going to see wireless tablets, laptops, printers, IP phones. Then we're going to see our intermediary devices, which if you remember, that's kind of our networking equipment. It's the device that's in between different hosts, and that allows them to communicate. And then finally, we have network media. So wireless is the little squigglies, black line is LAN, and then WAN media is the lightning bolt. And again, this tends to be a Cisco standard. This might be different with other vendors, or you might adopt your own kind of representations for these. A logical diagram or a logical topology is going to show relevant information. So it's going to have the IP address. It's going to have more information about like what that does, and then it's just going to be more of a theoretical, like, we can see that classroom 3 has a direct line to this Ethernet pipe, over here, and then it goes to the router firewall, and then it goes to the internet. But what you don't see is classroom 3 is not necessarily next to classroom 2. They could be on two different floors. That's where your physical topology is going to come in, because notice here we don't see a classroom switch. We don't see an Ethernet switch. All we see is just Ethernet, and then it hits a router or firewall, a different device type, and then the internet. Okay. Whereas the physical topology is going to show us, okay, classroom 1 has, these 1, 2, 3 devices, a classroom switch. That classroom switch goes to an Ethernet switch that's located in the admin office, and then it goes to the router. Okay. Whereas here we just have the, 7, 8, and 9. We can see that in this case, it has, 2 computers and then a printer, 2 computers and a printer, but this has the actual IP addresses. So this gives a little bit more information regarding, the IP address stuff. This is the actual physical layout of the building, and you'll use both in your IT career because they both do two very different things. The physical device or the physical topology is going to show you like a lay of the land. You don't really care about the IP address. You don't necessarily care about host names or anything like that. You want to see how the physical layout is. Whereas in sometimes you need to look at the logical topology, and you care more about like what are the IP addresses of these certain devices, and then what is the big picture as far as how they connect. Okay, so for example, the logical topology here at the where I work now at the Career Center is, I would have my lab, then it connects to Ethernet, it goes to a router, and then another router, and then it goes to or a firewall, and then another firewall, and then a router. So again, it makes all these hops, but I don't necessarily lay it out in, if I wanted to lay out how it actually connects and what rooms all of those devices are in, that would be our physical topology. So just to sum up, like what are some things that you should have full understanding of, and if you don't have understanding of it, then you need to let me know, because again, my job is to record my lecture so you can watch it, review it, and then spend time with you one-on-one in the classroom or online, if it's during office hours. So again, if you don't understand everything on this page, then either go back and rewatch the lecture, watch them with supporting videos, go through the labs, whatnot, and then if you still have questions, please let me know. Again, if you need to, we talked about this before, but it's important to know the different terms and commands. So these are the kind of key takeaways if you are creating a Quizlet or if you are doing some type of flashcards, whether that be Anki or creating a Kahoot. These are some of the terms that you are going to need to know for if you're taking your Network Plus, or just have knowledge of if you are going into IT and or cybersecurity. As always, if you have any questions, please feel free to reach out, tj@tjhouston.com, or message me in the comments below. Thank you very much, and have a good day.